Let's try this next acceleration calculation together. The next one, they're asking us to find the acceleration from 4 to 7 seconds. And I find it very helpful to just look at the data that I'm trying to analyze and exclude the other data from my view. So if I cover up from here to here and remind myself that these are my x coordinates, these are my y coordinates, then I think it makes it easier to think of 4 seconds as being data point 1, 7 seconds as being data point 2. So if I label data point 1, data point 2, then it's really clear to me that that's my x1, that's my x2, and here's my y1, and here's my y2. So I'm going to plug these values now into my slope formula. So my y2 is a value of 70. My y1 is a value of 40. I'm going to take that quantity and divide it over the quantity of my x2, which is 7, minus my x1, which is 4. And once I get that value in my calculator, so I'm going to do 70 minus 40, hit enter, and then 7 minus 4, hit enter. 70 minus 40, hit enter, divide that over 7 minus 4, hit enter, and then put that answer in meters per second squared, because those are my units for acceleration. The last one's going to work the same way. If I think about just looking at that data, again, this is my x, this is my y, and let's see, 8 is my first data point, 10 is my second data point, so now there's my y1 and my y2. I'm going to plug those in now to my slope formula. My y2 is 70, and my y1 happens to also be 70. So that quantity gets divided over, let's see, x2, which is 10, minus x1, which is 8. So 10 minus 8. So the quantity of that minus that, hit enter, divide that over the quantity of that minus that. That value goes here, and it's going to be in meters per second squared. Once I look at this next section where it says use your graph to calculate the slope of the line, the following points on your graph, well, you could use your graph or you could just use the data and plug these numbers into the slope formula just like we did up here. So the values are going to be the same for these answers as they were for these answers. The only difference is that slope is one of the very few things in science that does not need units. So these actually are going to be naked numbers. Let's take a quick look at our conclusions down here. If we examine the slope of the line within the first 7 seconds, did the slope change within the first 7 seconds? So is the slope curved or straight is basically what that's asking. Because it is a straight slope, without even calculating it, I know that the value of that was constant, so the answer for that one's going to be no. What does this tell us about the acceleration of the penny? A good answer for that would be something like that the speed is constant. The speed is constant because it was a straight slope. Question number 3, what does your graph tell you about the speed of the penny as it falls? Well, a good answer for that, and even just looking at our data, we could say that speed is increasing at a constant rate until it gets to 7 seconds, where the speed is no longer increasing, but at a constant rate, the speed stays constant. So no longer increasing at a constant rate, but the speed stays constant would be a good answer for this one. Question number 4, what happens to the penny after 7 seconds? Well, that's when it stopped accelerating. In other words, the speed stopped changing at a constant rate. It stopped accelerating. would be a good answer for number 4. And this appears on the graph as a flat or horizontal line. So go in this direction. For number 5, a good answer for what's the relationship between the acceleration and slope of a speed versus time graph. A good answer for that would be that they are the same. The only difference between acceleration and slope in this case is that acceleration has units. So that they are the same is a good answer for number 5. And what is causing the penny to accelerate as it falls? I bet you know the answer to this one is a G word that causes things to fall. The answer to that is it's acceleration due to gravity on Earth. And you might not know the answer to this last one. Why does it stop accelerating after 7 seconds? The answer to that one is it reaches something called terminal velocity. Terminal velocity is when things stop accelerating due to gravity on Earth and continue on at a constant speed because they're no longer increasing speed. The speed remains constant after it's reached its terminal velocity. We're going to look at a video on this that has to do with falling pennies off of the Empire State Building, as we read about in here, and I hope that you enjoy it a lot more now that you understand the science behind it. So thanks for listening, everyone. Thanks for your patience, and I hope you all have a beautiful day. If you do have any questions or want any help going over any parts of this at all, please just let me know. Have a beautiful day, everyone. Bye-bye.